Hey guys, our next problem is you observe a stone falling, but you do not see where it fell from. It has a certain initial velocity, but you only know that it takes 1.5 seconds to hit the ground. You know it fell 30 meters while you watched it. I want to know A, what is the final velocity of the stone, and B, what is the total height that the stone fell from? This one is a little bit complex, but this one also has a very practical application. There's a lot of ways that this could be useful. I want you to try and think about this as we go through the problem. Let's say I'm a crime scene investigator and I have a video of an apartment building, but the video only covers from the 5th story down. And I see evidence dropping from the 5th story down. I don't know where it came from. But because I see this part of the motion, I can use physics to figure out the rest of the motion. I can figure out which floor this evidence started from. And that could help me figure out where my perp is located. Or, let's say I'm walking along a ravine, I'm lost in the wilderness, and I need to climb up a cliff. I don't know if I have the energy or the strength to climb all the way up this cliff, but I see a stone falling. I know it came from the top of the cliff, but I only see the last bit of its travel. So I can figure out the height of that cliff using a problem like this. So our first step here is going to be to draw this out to make it simpler. So first, the ground. Our ground is going to be our 0 point, okay? And then we start seeing the stone here. The stone is falling all the way from up here, but we only notice it when it gets to this point. We know this point is 30 meters above the ground. Maybe there's a tree that we happen to know the height of there. We know that it takes it 1.5 seconds to finish falling. So, we know a few other things. We know acceleration due to gravity. We know that at this point, it's going to have a certain velocity. And we know at this point it's going to have a certain velocity. At some point way up here, it would have a 0 for an initial velocity. So let's go ahead and write out our equations, write out our variables, and we'll figure out together how to solve this problem. So we have our classic S equals xi plus vit plus a 1/2 at squared, and a is equal to vf minus vi over t. Then for our variable list, we're going to break this out into 2 parts because we're really looking at this motion and this motion. And then we're going to have to combine certain aspects to get our totals. So, part A, we're going to look at the bottom part because we already have a lot of the information for that. That's going to be an S, an XI, a VI, VF, A, and T. Then I'm going to go ahead and make a second variable list right away. S, XI, VI, VF, A, T. Now my part A is asking for the final velocity of the stone. That's asking for when the stone hits the ground, right there, what is my final velocity? So part A is asking for the final velocity in the first part of my problem. So this is A. Part B is asking what is the total height that the stone fell from. Basically, it's asking if this is my final position, this is going to be my S for part A. This is going to be my XI for part A. However, part B is this motion from here to here. So my XI for part B is going to be right here. And that's going to be what I know. That's going to be what I'm looking for. What's the total height that it fell from? That's going to be my XI for part B. Okay, so now I know what I'm looking for. At the very least, I know what I'm looking for. So now, what do I know? You observe a stone falling, but you do not see where it came from. It has a certain initial velocity, which means that's telling me it's not 0. That's supposed to be a clue within the problem to tell you, you don't know initial velocity. You don't know. It's not 0, you don't know it. But you only know that it takes 1.5 seconds to hit the ground. So we know t for part A is 1.5 seconds. We don't know if that's from its initial position. That's not that time. It's only for this last bit of movement. You know that it fell 30 meters while you watched it. So I know it hit the ground at 0. That's going to be my final position. And I know that it started in this motion that I observed at 30 meters. Acceleration. This is a free fall problem, so I know my acceleration. It is negative 9.8 because my position upwards is positive, so anything downwards has to be negative. Negative 9.8 meters per second squared. All right. Well, this is great. I can go ahead, and for part A, I can do S equals xi plus VIT plus 1/2 AT squared and solve for VI. Because I have an S, I have an XI, I have a T, and I have an A. So let's go ahead and do that. So S is 0 equals 30 plus VI times 1.5 plus 1/2 negative 9.8 and 1.5 squared. Excellent. Now we can simplify this by rewriting this really quick. Because addition and subtraction, it's always going to work the same way. Whenever we see a problem like this set up, to simplify it for ourselves, I want to merge this 30 with all of this. So I'm going to rewrite this as VI times 1.5 plus 30 plus 1/2 negative 9.8 1.5 squared. So now it's going to make it a little more clear for me. So 30 and this, I'm going to add all of it together. All right, adding all of that together is going to give me VI times 1.5 plus 18.98. So 18.98. So 30 plus a 1/2 times negative 9.8 times 1.5 squared is going to give me 18.98. That's all going to be equal to 0. Now, I need to get the 18.98 over to this side. So I need to subtract it from both sides. That's going to give me a negative 18.98 equals VI times 1.5. Now to find VI, I just divide negative 18.98 by 1/2, or 1.5, and that's going to get me negative 12.65 meters per second. It's equal to VI. So my velocity at this point is going to be a negative 12.65 meters per second. Now, that is right. That makes sense because it's negative. It should be negative. It's going downwards. If you got a positive velocity, but you still got this same magnitude, this same 12.65, I would advise looking up your equation. Likely, when you get to this 18.98, that's what I did the first time, trying to carry it over, you forgot to make it a negative. So, once we have this initial velocity, I can go ahead and find my final velocity and answer the first part of this problem. Negative 12.65 seconds. So I'm going to plug that into my acceleration equation. A is equal to VF minus VI over T. Rewriting to solve for VF is going to be VI plus AT. All right. I know VI is a negative 12.65 plus a negative 9.8 times 1.5. Plugging that into my calculator is going to get me a negative 27.35 is equal to my final velocity. Perfect. So writing that over here, negative 27.35. Box it off. Units on that are meters per second. Great. And I have officially run out of room on my blackboard, so I'm going to erase all of this. Hopefully you guys have started to see the value of using a notebook and writing this into the notebook instead of trying to use the tiny amount of space I provide on my worksheets. Okay, so now we need to look at part B. The way we do that is we recognize that all of our final conditions for part B are our initial conditions for part A. This is A, this is B. So, my initial conditions for part B, xi, position initial, is 30 meters. So that's going to be my S for part B. My initial velocity for part A is negative 12.65. That's going to be my final velocity for part B. My acceleration, it's a constant according to gravity, so that's going to carry over. Negative 9.8 meters per second squared. All right. I want to know xi. Well, currently, I'm missing 3 variables. That's going to be really hard to solve. So, is there any other variable I can fill in here? Either initial velocity or time. Well, I don't know time right away. I only know the time for part A. I don't have it for part B. But what I do know is that the highest point here is where the movement of this object initially started, which is always going to be a 0. If it starts moving there, it started from 0. Okay, so my VI for part B is going to be 0 meters per second. That's fantastic. Suddenly, VI, VF, A, I can solve for T using my acceleration equation. So let's go ahead and do that. So part B, A is equal to VF minus VI over T. Rearranging it to solve for T, T is equal to VF minus VI over A. Plugging our numbers in, that's going to be a negative 12.65 minus 0 over negative 9.8. And that's going to get me a positive, should be positive, it's a time, of 1.29 seconds. Fantastic. So 1.29. And now I have everything I need to plug into my S equation and solve for xi. S is equal to xi plus VIT plus 1/2 AT squared. Plugging in for my variables, 30 is equal to xi plus a negative 12.65 times 1.29 plus 1/2 negative 9.8 times 1.29 squared. Whew! All right. We're going to combine all of this into one term. Because we have all the numbers here, I can just multiply these together, multiply all these together, and then add these together, and perfect. That's going to get me a negative 24.47. Now notice, I like to put a plus negative in here, because that helps me to remember that this is a negative number. I could also write this as 30 equals xi minus 24.47. But when I do that, I personally have a tendency to forget that this is supposed to be a negative number and just drop this integer. And I end up with my answers all having the wrong signs. So this is how I do it. That might help you if you're having trouble with integers. So the way I'm going to solve this is I'm going to move my negative 24.47 to the other side. Now, 30 minus 24, plus, because I'm getting rid of a negative, 24.47. Sorry, as I'm doing it, I'm trying to make sure it makes sense as I'm talking. So 30 plus 24.47 is equal to a 54.47 meters. So that's my xi. So does that make sense? Yeah, because 30 is right here, and it should have fallen from some height above that, 54.47. That does in fact make sense. 54.47 meters. Now, there is another way that you could go about solving this. You can solve it however you want, however makes sense to you. If you think of another way, that's great. Another option that's pretty common for a problem like this is to then treat this as its own separate motion. And so instead of using all of your same reference points, you would actually instead change your mind and say, okay, well then my new reference point for part B is going to be right here. And then I'm going to use that as my 0. And then when I want my total displacement, I'm going to say S1 plus S2 equal to S total. If that's a little confusing, don't worry about it. But if that's a way that makes more sense to you, to treat these as two completely separate problems and then find your totals and then merge your totals together, that works too. All right. Thanks, guys. I hope that makes sense.